change this into x, y, z from the spherical to rectangular. That's your first line. Your x is going to be rho sine phi cos theta, y is rho sine phi sine theta, and z is rho cos phi. Rho cos phi. This comes from Pythagoras. Let me give you an easiest example. So for the z, think of the z. The value set here is a measure from the origin to its height. And this one is rho, right? This one is rho. The height here is z. So by Pythagoras, z is adjacent to phi, right? So from Pythagoras, z is going to be rho cos phi. You can do likewise for x and y, but that you have to do 2 times. You have to project down first, and then you use trigonometry for x and y on the floor in order to derive x and y as such. Okay? But if you don't care, say I want to just nail the x, memorize the formula. It's long. So x is rho sine phi cos theta, y is rho sine phi sine theta, z is rho cos theta. And the latter one, which is perhaps more important, because you're going to see the integrals in rectangular coordinates, and then you change it to the spherical one. You're going to change rho to be the magnitude of OP. So it's just the square root of x squared plus y squared plus z squared. So the second line. And you start off with x, y, z in rectangular. You change it to the rho theta phi spherical. Rho is square root x squared plus y squared plus z squared. Tan theta, if you take a look at the first line, you see that y over x is rho sine phi sine theta over rho sine phi cos theta. So it's just tan theta. So that's why, in order to find theta, you're gonna do y over x, big tan, and then compute the theta. And z is cos phi. So z over rho is rho cos phi over rho, which is cos phi. This we will use to find the angle phi. The angle from, well, the geometrical perspective is also important. This is the angle from the positive z axis, and then it's like it's going, I don't know, it's expanding and go down. It's like a pin of a clock starting from the 12 o'clock, and then you keep moving down. So can you tell me what are the possible values of phi? Phi will start from 0, where positive z axis is measured with itself. So that phi is 0, right? And then you keep going down. Your theta angle, your phi angle is increasing, and then you aim at the negative z axis. That's the most you can get, which means your phi starts from 0 to the straight angle, right, is high, right, from 0 to high. So let me give you some digestion. So suppose you have that, your phi keeps going down, and when it reaches the floor floor level, like perpendicular to the z-axis. This is when your theta is pi over 2, right? Because they are perpendicular to each other. But then you can keep going, keep going. So your biggest angle here is 3 pi. So typically, phi will go from 0 to pi. It will be in this range. But which angle is it? It depends on the problem. Theta ranges from typically 0 to 2 pi, like the polar coordinate. Another equation that I think I find slightly useful is x squared plus y squared. This is going to be rho square sine square phi cos square theta plus rho square sine square phi sine square theta. They have a common factor, rho square sine square phi. These are the same. And once you factor it and then you accumulate the cos square theta plus sine square theta, they will become 1. So we can reduce this to rho square sine square phi if you want to. That sometimes may come in handy. Alright, let's try to do things like brute force first. So the first one, I want to convert the point 0 to square root 3 minus 2 from the rectangular coordinates to the spherical. So for number 1, I will compute the rho. The rho is square root x squared plus y squared plus z squared. So square root 0 squared plus 2 square root 3 squared plus minus 2 squared. 0 plus 12 plus 4. So root 16, which is 4. And tan theta, this is y over x. And notice that the y over x is some non-zero number 2 over 0. It's undefined, right? On which theta, the function tan theta is undefined. Pi over 2, right? Maybe you have pi over 2 or 3 pi over 2. You have to check the sign of y also. So in this case, theta is pi over 2 or 3 pi over 2. But look, the value of y is positive. So you eliminate the 3 pi over 2. This will not count. And for cos phi, you compute by z over rho. This is minus 2 over 4 minus 1 over 2. So phi is going to be cos of which value is 1 over 2?
Pi over 3.
pi over 3. So you shift it to second quadrant. It's going to be pi minus pi over 3. Right? So it's 2 pi over 3. So from x, y, z, from 0 to pi over 3 minus 2, which is rectangular, we change it to spherical. You get for theta first, theta is pi over 2, and phi is 2 pi over 3. For the second one, I would convert the point to pi over 4, pi over 3. It is from spherical to the rectangular one. So x, the formula is pretty long. Rho sine rho cos theta sine phi. Y is rho sine theta sine phi, and z is rho cos phi. So for this is spherical, so it corresponds to rho theta phi, right? Rho theta phi. Well, I write it like swap from this, but you know they're the same, right? This I write as rho sine phi cos theta. I think I prefer writing this way because it will align with rho theta phi, not to confuse with the swap. So it's 4 cos pi over 4 sine pi over 3. So 4 square root 2 over 2, and sine pi over 3 is square root 3 over 2. So it's root 6. Oh, sorry, it's 2, right? So it's square root 6 over 2. Y is 2 sine pi over 4 sine pi over 3. This is 2 sine pi over 4 is square root 2 over 2. Sine pi over 3 is again square root 3 over 2. So square root 6 over 2. Rho cos phi 2 cos pi over 3, which is 2 1 over 2, right? 1. So the x, y, z is going to be square root 6 over 2, square root 6 over 2, and 1. as usual, we just change points from like two systems. Now we're gonna change equations from one to another. So maybe I will do some of them which I think is more useful, some which I think is much less useful. I will not do it to save time because there are some other words which take so much time. So the first one is x squared plus y squared plus z squared. Rectangular to the spherical. So the first one is just rho squared is 9. So rho is 3. For the second one, I will compute once again. This is a half cone, right? This is a half cone. The ice cream cone. So this is r squared cos squared theta sin squared phi plus r squared sin squared theta sin squared phi equals to r cos phi. This will correspond to what? It will correspond to r squared cos squared sin squared phi cos squared theta plus sin squared theta equals to r cos theta. R cos phi, sorry. This becomes r sin phi equals r cos phi. Sorry, I mean rho. I keep confused with the semicolon. It has to be rho. You see, identity cos squared plus sin squared is 1. The reason that we don't take absolute because rho is the magnitude. It's usually positive already. Okay, we also take absolute first. Oh, shoot. And phi usually ranges from 0 to pi. So sign is always positive, right? This is positive because phi is ranging from 0 to pi. So this reduces to rho sin phi is rho cos phi. I don't care about rho being 0. So you just get tan phi is 1. So phi is just the pi over 4. That's your final equation. For number 3, I'll skip. Again, it's a saddle. It's kind of useful in terms of explaining the saddle point that we did before midterm. In terms of integration, the saddle point will be the saddle is going to be very negative. So I'll skip it. We mostly deal with cones, maybe paraboloids, and spheres. These are like maybe ellipsoid. These are mostly we going to deal with, and planes, of course. So for number 4, I changed the left-hand side to rho squared, right? The left-hand side is rho squared. The right-hand side is to rho cos phi. This you change it to 2 equals rho cos phi. Also make sure you follow. I'm not sure. So if you just can, these are formulas that we have to use. We're gonna use this in the box. I told you, finally it's very difficult. This is just the beginning. Okay, next I will convert this into a rectangular coordinate system. So the first one row is 3. It means that the square root x squared plus y squared plus z squared is 3. So just take the square. This is just a sphere of radius 3. For theta in pi over 2, what's the best approach to do this one? Tangent, right? Tan theta is tan pi over 2, which is undefined, of course. Undefined. But you know that tangent is y over x. Which means that x must be what? 0, right? The unit has to be 0. Phi is 2 pi over 3. What's the best strategy? Cosine. Cosine, right? We have rho cos, phi is that. So I will come and take cos. Phi is cos 2 pi over 3. Cos pi over 3 is 1 over 2. So 2 pi over 3 is minus 1 over 2. So what will I do next is I will multiply the equation with rho to change the left hand side to set rho cos phi is minus 1 over 2 rho. So set is minus 1 over 2 square root x squared plus y squared plus z squared. If you want to know what it looks like, take the square with a remark that z now must be negative because it's minus 1 over 2 square root. So I'm going to square on both sides. I get z squared is 1 over 4 x squared plus y squared plus z squared. And then I do a little bit of algebra. I get to this form. The equation for this one is, the surface is the cone, right? It's a half cone because z negative. So instead of the full cone, it's a half cone facing down, right? Because z is negative. So this is half cone. Facing down. And the fourth one, I use, remember that we have x squared plus y squared is rho squared, sine squared, phi. So for this one, I'll do square first. So rho sine phi square is 2 square. So this is rho square sine square phi is 4. The left hand side is what we just did. This is a formula for x squared plus y squared. This one set is free, right? Which means this surface is the cylinder. Cylinder is a circular. So circular cylinder. I mean, you can say more by saying that the cross section is going to be the circle of radius 2. This mimics the equation of the circle in 2D. So it's in this form. Alright, now it's time for the main course. For the triple integral with respect to the spherical coordinates. Of course, we have to change your domain of integration to the spherical form if you think it's the best way to do. And okay, I assume that you don't care about how to calculate, like cutting the concept of integration, cutting into small pieces, small wedges of the circular rectangle. And you measure the small piece, calculate the very small chunk, that'll be fine. You get something like this, whatever, right? But once you compute this, okay, the main idea is you use classical geometry. This you transform into the rho, the theta, the phi. Once you take limit, like you cut into smaller and smaller pieces, you take limit. This will become the rho, the theta, the phi. The extra factor, you remember the spherical one, you have the extra factor of r, right, for when you integrate. For spherical one, your extra factor is going to be very different. It's going to be rho square sine phi. This is your extra factor. The session after this, we're going to have the most generalization of this. You're going to compute using some sort of Jacobian. But all in all, what we care the most is, okay, the formula is going to be in this form. So first, you change x to rho, sine phi cos theta, rho cos theta sine phi, let's say. Assume that you may prefer rho cos theta sine phi and rho sine theta phi. This is your x. Your y is rho sine theta sine phi. And z is rho cos phi. Next, you have the extra factor rho squared sine phi. The rho, the theta, the phi. Okay, let's deal with the simplest domain as possible first. The simplest case is when the domain is a sphere, because that aligns well with the how spherical coordinate system works. So the sphere of center 0, 0, 0, that's going to be the easiest case. So I want to evaluate this triple integral where b is the unit ball, x squared plus y squared plus z squared less than or equal to 1. So it's just a unit ball, and it's 3D. And how do we measure possible values of rho, theta, and phi? Let's do one by one. Your rho is going to be measured from the origin to the outermost shell. So rho starts from origin to outermost surface. So it's like it's radiating from the origin to the outermost one. So this is a whole unit ball, right? Inside is solid. So we start from origin, where we already start to count. So rho will be from 0 and expanding outward, hitting the surface of the ball. And the surface is described by x squared plus y squared plus z squared equals 1, because that's the outermost layer. This corresponds to rho squared is 1. So rho is 1. How about the theta? The theta is like you are trying to sweep a plane. So we start from this positive x-axis. You rotate on the floor. Okay, you look at it as if you are rotating on the floor. Starting from, this is when theta is 0, and then you rotate counterclockwise. This is counterclockwise. Counterclockwise. Like how it works in polar coordinates. So you keep rotating in this orbit. But it's a solid ball, so it will take all of them, right? So it will take a whole round. So your setup will complete a full run. It will start from 0 to 2 pi. And the last one is phi. Phi is measured from the positive z-axis. This is when phi is 0. And then you are radiating this axis down, like it's like you are opening. I don't know, opening something. So you keep radiating. It still hits the region inside. It keeps going until the end. What is the end here? The end is when the axis hits the negative z-axis. You get the idea, right? Zeta 0, and then it keeps like opening up. It's like a cone. Okay, you open it like a cone. So your zeta, your phi is increasing, and it keeps increasing. When it hits the floor, your setup, your phi will become pi over 2 because it is perpendicular to the z-axis. Getting idea, right?
ฟีเปิดทั้งสองฝั่งเลย
Yeah, it will open on both sides. Usually we deal with fairly simple surfaces. So this has like high symmetry, like it is highly symmetrical, right? So opening on any side, the angle will be the same for this one. So you keep going. So it looks like a cone, but when you measure the angle from any direction is the same. Okay, let me draw this way. Suppose you have plus z and minus z. This is 0. The way you measure the angle phi, you start from the plus z axis. This is when phi is 0. And then you keep opening in cone trace. So for example, when you open a bit more, your angle phi is going to be this guy. Okay, keep opening in contrast. This is your angle phi, but if you can visualize 3D good enough, measuring in any direction, you get the same angle. Right? From this to the right, from this to the left, from this to the behind, you get the same angle. So your phi keeps moving down. We are still taking it because it still lives inside the unit ball. At the floor, so when you open the cone, it's like you fully expand it. Your phi will become pi over 2. Because you measure from the positive z-axis to the floor, and they are perpendicular. So your phi is pi over 2. But it keeps going. So keep going, maybe like this one. I'm not saying that we are having a domain as a cone, okay? We just try to measure the phi. So when you go more, your phi will start to be greater than pi over 2. Maybe 135 degrees or something like that, like 3 pi over 4. Until your cone starts to wrap up itself and stop, it accumulates at the negative z-axis. That is when it ends. Your final angle is phi being pi. Final phi is pi. Okay. Once we get this, the rest we plug in the formulas. So the triple integral of the x squared plus y squared plus z squared 3 over 2 dv I'll try to do d rho d theta d phi. Rho is from 0 to 1, theta is from 0 to 2 pi, phi is from 0 to pi. Oh, by the way, we're going to have extra time from today, remember? So if have another 30 minutes from like until 11:30. So maybe we'll give you a quick break or something at some point. Maybe after this one. So x squared plus y squared plus z squared, that's rho squared, right? This is your rho squared to the 3 over 2. Of course, don't forget the extra factor, rho squared sine phi. The rest we integrate. Rho square takes root. You have rho cube multiply rho square is rho to the fifth. Sine phi d rho d theta d phi. Continue this, you get 0 to pi, 0 to 2 pi. Rho to the fifth, sine phi is constant. Take it as a constant. So you're going to integrate rho to the fifth, get rho to 6 over 6 from 0 to 1. Rho 0 to 1. D theta d phi, which is 1 over 6 sine phi d theta d phi. integrate with respect to zeta is zeta itself because phi does not phi is independent of zeta. So this is just sine phi times zeta from 0 to 2 pi d phi, which is, sorry, we have 106 times 2 pi integrate 0 to pi sine phi d phi. Negative minus 1 minus negative 1. So it's 2 pi over 3. Okay, I'll give you some break. You come back at 10